Okay, welcome back to the lab. We're quickly gonna do the lab now. I'm gonna share my screen here. So we are essentially seeing now the data of our lab. This is essentially consistent with what we have seen in class. And essentially we are loading the library even. We're opening the read SPSS file. Uh-oh. Okay, so we're loading the Haven library. We're essentially loading now the chain data set. It essentially gets us here the 532 observations. So we're looking at this the same way as we have looked at in the lab. So we have here log virus, we have missing data, and we can investigate this in more detail later on. So now we have the univariable fit, which is essentially log virus as a function of the treatment. And we can now run the multivariable model that essentially allows us now with the Stargazer library to stargaze at our models. So now we essentially we're getting this model that we have looked at in the lecture. So these are these estimates that are essentially comparable but somewhat larger in the univariate model as compared to the multivariable model. So there was some confounding that happened. Now we're loading the mice library and we're loading MD pattern. This will essentially get us exactly that overview that we have seen in the lecture. We're seeing the number of entries where we have 0 missing values. We're seeing 122 that have 1 missing log virus. Then we have damage is here. These are 9. Then we have 28. So it's essentially it's quite presenting with some missing data. So if we are investigating now, so these should all be consistent with these counts. Log virus missing in 197, consistent with this. 24 in treatments, healthy mental damage 63, which is consistent with this. So we see all these different NA missing values shown. So now we essentially we're loading now. We're loading now our data set. We're changing things to factors, and we're now going to names chain. So we have now exactly our 7 variables included. And now we're doing exactly what we did in class. So we are using with the mice function, we're using chain. We do 50 multiple imputed data sets. We're doing PMM, 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 PMM. So this is the mean matched approach with the logistic regression for the binary variables, and we do ordinal logistic regression, polytomous ordinal regression for those with more than binary variables like damage, for example, is from 1 to 5, it seems. We can always load package documentation for the function. So if we load here the package documentation for mice, we see this all mapped out. So we see the methods mapped out. We see all possible objects. So we have the predictive mean matching. We have here we have the log reg, the logistic regression, and here we have the polyreg, which is the polytomous ordinal logistic regression, proportional odds model. Proportional odds model. Nice. So this is actually another polytomous logistic regression. This was proportional odds model where you calculate the odds in an ordinal fashion. So it's not polytomous, although it would apply. Yes, it would, because it's a polytomous variable. So yes, so it's a polytomous proportional odds model. So you do a proportion and you calculate the odds for each proportion. Print flag false means that we're not looking at what's happening in the background. So we have done that already. So let's set this now for the sake of presentation to true. And let's look how this maps out and what it actually shows. So we are seeing now how this essentially runs through and how R is essentially building these different imputed data sets. And this goes considerably fast. So basically creates models for each of these different sample subsets and essentially creates these different data sets using Monte Carlo simulations. Already halfway through now. We're at 35 now. I'm changing this back to false. And this will not be it. Okay, 43, so it's done. And 49. 50. Good. That basically uses a second approach to that. Okay, here we'll stop it. So essentially we're doing this now only 10 times. Pause the record. Okay, so with 10 it was substantially faster, obviously. Change it back to 50. The final one will contain 50. So if we are looking at MI results, so that's now we're building essentially with our data.mice object, we're building now mice fit, and we're pulling these results together. So if we look at mice fit, this will show us all the different models, right? So this is 10 different models and 10 different multiply imputated subsets. So this is obviously different estimates. And now we're pooling this and we get here pooled result. And we get here the estimate that essentially is to some extent comparable to what we've seen in the original model, just like we discussed in class. So this is essentially all that I have from Marcel and Bino here. And this is basically just the raw code. Okay, so this was multi-beam imputation, a very useful method. So I hope the code will be useful, and my walkthrough was somewhat useful as well and insightful. please play around with it, try different ways of approaching things. And well, it's been a pleasure. That was the last class in the last lab. So I hope the next 2 weeks we're going to have a chance to converse about some aspects of the research note, for example, over discussion board. Let me know if any questions. If you want to hop on a one-on-one, we can always schedule something. And wish you a good rest of the semester, and we'll talk soon. All right.